Hi everyone, my name is Kiran Salve, and we are doing analysis on web server log analysis data. Actually, this is HTTP request data from the University of Calgary Computer Science web server data. So actually, we have to load the data and clean. Okay, actually. That we have to do some data loading and cleaning. Download this file, that is the extension of file is .gz. This is a compression in compression format, and we have to read that and load into Python, suitable Python structure. So we are reading the data. So for that, we are imported. This is Jupyter notebook. In the Jupyter notebook, we are importing panda as pd and tk enter as tk, and here is the file path. That means we have given here the option to choose the file and read that the file. So, and for the how data look like, that we use the data structure as pd.read csv, and here we get some idea about the how our data look like. So we are running this one. First run, and we can see that we are running this file and we get this fifth number here. Previously it was the 4, and this means our data is ready to display. Actually, print.def on that shape. So this gives the clear idea about our dimension. This is row and column, and the 5 lines, rows. So we are reading this one also. So this is our data look like. Now converting data frame into data frame, that for the analysis. Initially, we have to split column into desired data frame. Why we are saying that? Because this is column 1. So we know the for Python it's starting from 0, 1, 2, and dash 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 and so on, for the infinite. Actually, this one. So for this, we are displaying this one, like how our data look like. So this is row 1, row 2, row 3, row 4, row 5. As we mention here, head 5. This means it will give the 5 row, and we have only one column, so that is the 0 number column. Okay, so initially looking into the data, we can clearly see that this is one keyword, this is second one, third one, in between there is a space present, and this is into the square bracket. This is one data, one word. This is another in the double quoted, and after that the space, and the 200 space, after that the space, and 150. So we have to clean this data set and split into the multiple column. So look what we have given. Okay, so we have given this is the remote host. So this is the remote host. Okay, 1 minute. This is our data structure. What we have to we have to compare this data structure with this given format. So first one is the host. So this is in between that remote or local. This is one. Remote is used for external, and local is used for University of Calgary. After that the timestamp, requested timestamp, this is like the Monday, October 24, and this is time, and this is the year, the file name, which is the anything, and dots, file type. This is, here we can see that 1234.html. so .html is our file extension. So HTTP code, this is like response status code, like 200, 404 and 500 byte is the size for file. So we are reading this one. So we have to split data in multiple column, so that we import which is present in the pandas. So this we create the if the file path and into the square bracket the data. So as we know that we are doing, why we are doing, we are explaining it that because we know that this is the data structure, this is our data structure, and what we have to look at this one. So this is basically for this one. So what is this one? The match first non-space string, non-space string, this is first one. So this is non-space strings. After that /s plus this one or more spaces. Okay, so this reading this one or more spaces, same this one into the round bracket /es plus, this is match the second non-space strings. This is non-space strings means this one. Okay, similarly for this one /es plus one or more spaces, then this is the reading this one. Okay, so similarly this one, and for this one, so here we can see that this one slash into square bracket. So this will give the match timestamp inside the square bracket. So whatever inside the square bracket, whatever inside the square bracket, this we called as our timestamp. So similarly for the whole this is, so this is the splitting. We are matching this one to this one, and now we are opening this file which is stored in R, and match is equal to pattern.match line. So if this match, so first, for the first we choose as a column name as a host. For the second, which is this one, we consider RFC 931. So this is the authentication we user, this one, timestamps, this one, request, which is again into the double quoted. So double quoted, this one, this is we use for double quoted, match the requested line inside the double quote. So request match this one total. After that HTTP code match 200 to this one, and byte send match group this one. Okay, now we are running this one. So this is running. Here we are looking the start. This means we are running the code. Okay, look how it's look like that it's separate this. Using this we separate this total row into the multiple column, like first local RFC931 author, timestamp, request, HTTP code and bytes. Okay, this much line are read by the Jupyter. Okay, this is we explain already. Okay, now basic column wise analysis we are doing. So if we are running this, let's see what happen. Column analysis, df.describe, this will describe the whole summary, and the dot transpose means it will use column as the row and the summary in the column format. So we can see that host has a unique count to total count is this 724836. So we get some idea about that. Now observing about data frame, we can clearly see that we do not have problem with the column host, RF, authentication user, timestamp, HTTP code and bytes, because this will give over the clear idea, local dash dash timestamps, HTTP code and bytes. But we have problem in this one, requested. Let's see what is our problem. See, as per our need, we have to transfer timestamp into the date time. As we earlier know that we have to transfer. Okay, we have to transfer this one. Okay, timestamp into string into the date time object. Okay, and HTTP code and bytes with maybe the integer or any other type. But so observing this variable, first we look into the variable request. So we are looking into the request variable. Okay, this one is the request one, this one. Okay, before the file name we have some word, and after the file name we have some word that we have to clean. We can use the space as a separator for cleaning. So using space we can remove this one as before word, before the first word. This is means this one is our word and we have to clean this one, and after that one space is there and we have to clean this one. Okay, so we are running this one. This is the code, extract the first word before the space. Okay, first word before the space. This is df.request.string extract the first word. Okay, and we are counting this df.method using this one method, that unique numerically unique value how many, and print, we are printing this one. So we are getting the 3 unique values, and the value of we are found is get, post and head. So we have to clean that one. Okay, we have to clean that one. Now removing that 3 keyword, df.request df.request.string replace this 3 one. Okay, so we are getting the clear idea. We are printing the df.request, so this is replacing with first word, replacing with the blank. So we get this one. So in front of this we have get, we had a get, so right now it is gone. So we get index.html. now same for this one. Okay, same for this one, we extract the last word. This is after the space, this word, and we get 80 unique values, and all this what we have inside the data frame. Now removing that word. Okay, we are removing. Same, we are removing that word, and we are get the clear idea about the request. So now we have index.html, one dot give index.html, and so on. So our request column is now clean. So we are making data frame that hosts timestamp, request, http code, and byte. Okay, this one is read. Okay, now we are counting the summary. So first count unique and missing value. For the host, count is length of the data frame is this one, 72, 48, 36, and this means 7,24,836 unique value are 2 missing value, 0, 0, 0. In all this, the 0 missing value. So this is the from this code we get the some idea about the missing value and count and unique value. Okay, now timestamp converting. We are converting the timestamp into the date time format. So pd dot to read date time data frame and which column we want. So this is the column name and format, in which format we want date, month, year, and hours, minutes, seconds, and this is the time zone, and UTC time zone is equal to true. Okay, error. So we are reading this one also because we want in this particular format. So we are reading timestamp. This star means it is reading the Jupyter file or converting the timestamp into the date time object. After that, print a df dot data frame types. Give the clear idea about the data frame, what type of the variable we have. Wait for a minute, it's still running. Okay, it's done. Now print data type. So host is holding the objects timestamp and date time 64 UTC, request object HTTP code integer, data byte integer. Okay, now extract the file extension from the file name. This is means we have to extract the file name extension. So we know the extension .html. HTML means the extension .gif. This is the extension. So we have to extract all the things after this full stop or dot. So we are extracting df dot this is extension, df of extension. We are making new column df dot request. So request, from the request column we are extracting. What we are extracting after that, whatever the alphabet numbers or the punctuations are present, so that we are extracting. This is running. Okay, making. Okay, it's done. Now let's look. Host timestamp request HTTP code byte extension. Here we get the extension column. So this is the replica of dot after the dot, HTML gif gif, HTML. So like that. Okay, handle the missing value. Missing value from the entire dataset. Now we are checking for the missing value. Actually, initially we don't have any missing value. Let's look. This one, we don't have any missing value, but we added one column. This is extensions. So if we are getting some missing value, then we are pre-processing it. So actually running this one. So now we get the from extension 1440 are the missing values. For the handling that, now we can see that the extension has 140 missing values, and now we comparing this extensions 140 440 values with the request. Okay, now we are running this one. This is the print null value. Okay, null value, this one. This is printing this null value. Okay, so as we can see that in the request we have this data, we have this data, and extension, this is NA value present. So in the request we can see that this code 568.map, it is not mapping correctly, or for this one, this is not mapping correctly. So this is not mapping correctly. So because this is the slash is present there, this is forward slash is present, it's there, so that's why it is not extracting the whole extension. So we are doing. Okay, our observation, what we say earlier here is, we can see that after extension having some alphabet, punctuation and numbers are present. This one are present. For tackle this problem, we extract the unique value from our previous extension variable. So actually in the previous extension means in this extension we have some values, because the data dimension is more, and only we have the 1440 missing value. So we are making we are extracting all the unique value from the extension and remove all word after the extension. This means after this extension whatever is present in this request, we are removing them. Then again extract the file name, and after that we are try to extract the file name and check the null value after this 4 process. For that unique value extension drop NA, actually get unique value extension, so we get unique value dropping NA, means no NA include. So we are doing this. Now we are regex pattern, we are building the regex pattern to remove everything after our extension. So this is 21 and this is 22. This means it is done. Now extract, so apply on this is clean dataset, and df dot request is equal to df dot request dot string and replace uh, this one, this first one. So we get the clean request. So after that we are extracting file extension. Okay, we are extracting file extension from the new requested. So we are also running this one. Okay, now print is null. So actually we get 134 null value, we can see that. And this one is also having some problem in request, but we are not going into that because again we read the summary. I am coming to the point why we are not going for the 134 missing value. Again we are going to count unique value and missing value from the data frame. Actually missing value is as same as the extension for the extension 134. We are not going for pre-processing this value, this in the present in the request, because we have 134, the missing value is present, as compare the percentage of the missing value divided by total number of rows into the 100. So we get the percentage, how many percent of the missing value is present in there. So if this is calculated, then 0.018 means 0.01% is the missing value is present in our data set, and this margin of error, so we can accept this is lower of very low margin of error. So this means we are ignoring this 134 value, 134 value. Okay. This is whole about the pre-processing and data loading or data cleaning. Now the second question, count the total number of log records. This means from the original data frame, how many rows are present in the original data frame. So for that one, we define the total log records as integer is equal to as integer. So this will return the length of df1. Length means the total number of the row. So we are reading this one. So we get this answer. This is a 7,26,739 log records. So if this is log records, okay, total log records, and running this one again. So total log records is 7,26,739 records are present. Similarly, for the count of the unique host, again we are defining one function, define unique host count, which is again also we want in integer. So this is df.host, that unique host, this is numerically unique, and we are running that. This is 2. So we can see that also the unique host as 2. We previously know that this is the confirmed by this code also. The unique count of host is 2. Date wise unique file name count. So for that we are doing from typing import dictionary, because why dictionary, because see the question number 3. Date wise unique file name count. So we have to extract this into the dictionary. So we have to extract this into the dictionary, like for the each date count the number of the unique file name that access the server, and date should be added there. And in finally we want result into the dictionary, as dictionary mapping each date to its unique count of file name. This means like example 1st July of 1995, 123 files, so like that. So for in the date time format, so we are making one another column, date format is equal to df.date time into the only day, month and year format, and unique file name as per the date. So we are using the dictionary, okay, for doing this one. For the dictionary, in the dictionary we have string and integer. String is the name and integer is the count right now. So dictionary df.group by means group by the total data frame by date format, for this one date format, and from this the request, because we want the file name and our file name is stored in the request dot numerically unique, number of unique, numerically unique means number of unique values, and dot sort dot value ascending. So we want in ascending order, and return unique file name as per the date. Okay, unique file name as per the date wise. Okay, return this one, and we want the count. So we are running this. Now this is taking time because it converting the timestamp into the only date, month and year. So we can see that 31st March 1995, the unique count of file name is 1006. So we can clearly see this output. Now going for the question number 4, number of 404 response code. This means HTTP code. Response code means HTTP code. Okay, response code means the HTTP code. Okay, we are adding this one. HTTP code. HTTP code is equal to the our response code HTTP. So for that, count 404 errors integer. This is the response code. So we are extracting the length of data frame HTTP code is equal to 404, means in HTTP code whenever the 404 is occur, that length. So we are printing that answer 4 is equal to count of this one error, and printing number of 404 response code, total number of, this is 404, total number of 404 response code is 23,517. Now top 15 file name with 404 response. So for that we have to make list using tuple, string and integer. This is the define function. Top 15 file name with 404 code is equal to the list into square bracket tuple string and integer. So in get the what we desire, what we want in desired format. So for this, the count of HTTP code data frame of that column, this column HTTP code is equal to 404 from the request, okay, from the request, and the count is blank. Value dot count means we are counting. Dot head 15, so because we want 15, top 15. Now return the file name. This is the file name, HTTP code and request. Count for the file name, count in counts of item. So we are counting in this file and we are running because the top 15 file name, okay, this is the top 15 file name. 1 2 3 index.html is first one, and then 4115.html is the second one, and 1611.html is the third one, like that. Top 15 file extension with 404 response. Now we want only the extension. So same count from the data frame, from the HTTP code column is equal to the 404, and from the extension we want count and we want top 15. So we are that returning extension count from the extension, count in the counts of item, count in the count of this item. So we are running this one. So we are getting HTML as highest. This is the 1,23,000, okay, 12,343 count. Total bandwidth transfer per day for the July month 1995. So we are defining the object, define the function total bandwidth per day, dictionary, string and integer, because here we have given we want the output in this format, dictionary format. So July 1995 we are extracting July month from data frame, from the timestamp called variable or column, dot year is equal to 1995, and from this same column, date timestamp, dot dt dot month is equal to 7 means July. So July 95 of date is equal to July 95 timestamp dot in which format we want that date, month and year. Now result in the format July 1995 dot group by date. So we are grouping by date and bytes. Bytes dot sum as type integer to dictionary. So we are reading this one. We are getting total bandwidth transfer per day for the July month. Let's see, 1st July, 2nd July, 3rd July to up to till 31st July. So for 1st July, this much of bandwidth, bandwidth required. Bandwidth means sum of the byte or size. Hourly requested distribution, same, defining the function hourly requested distribution dictionary, because we want this output in also dictionary format, integer. So we are also defining the count for the timestamp dot hourly in hourly time frame, dt dot hour dot value counts and sort index, and return integer hours into integer count for the hours and counts. Okay, so we are running this one. We will get from the 0, this means June, 30 June, this is end or starting of the 1st July. So which is 0 hours, this one, first hours, this one, second hours, up to the 23 hours. Okay, top 10 most requested data frame, top 10 most requested file name from the data frame, requested file name. Okay, defining the function top 10 most requested file name. We want in list format, tuple, string and integer. So count from the requested column dot value dot count dot head of 10, we want 10. So file name comma count, for the file name in file, count in the counts dot item. So this is giving top 10 most requested file name, index.html. This is the 1,40,074, like 3.gif on the second highest. This is 24,006. Okay, now last question, HTTP response code distribution. So we want also the output in dictionary format, integer and response code distribution. So we are defining this function, response code distribution. So we are counting df, means from the data frame, HTTP code, the value dot counts, and we want integer status into the integer count for the status, and count in this count. So we are also running this one. We will get the HTTP response code, means our HTTP code for the 200 5,68,345 for 304 HTTP code. This one is count, so this one. And thank you guys. This is the all web server log analysis which is given by which is given for our assignment, and we are completely did it on Python Jupyter notebook. If you have any question, please let me know in comments so that we can solve it. Thank you.